rectangles and squares, but we're going to be talking about some other polygons as well. So all these figures, they are all parallelograms. Okay? Parallel sides, congruent sides, it's saying it's a parallelogram, so we know these things have to be true. Parallel sides that are congruent, parallel sides that are congruent. These are specifically named figures. We know a rectangle and a square. They are also parallelograms. So we can use the label parallelogram for any of those three. Now when we get down to rectangle, this one is not a rectangle, right? Why? What's the difference between this one and these two? Morgan? It's what? It is slanted. I'm right? It doesn't have 4 right angles. You're right, it is slanted, but that's why it's slanted, because it doesn't have 4 right angles. So these two are rectangles and also parallelograms. So they're parallelograms, but they're more specific parallelograms, they're rectangles. So what's the difference between a square and a rectangle? Because the square we see is a rectangle, right? So how are the rectangle and the square different? The square is a rectangle. By definition, that rectangle, opposite sides are congruent and has 4 right angles. What's the difference between a rectangle and a square? Annalena? Yeah, so a square, all 4 sides are congruent, right? They're all the same length, which does mean that opposite sides are congruent and it has 4 right angles. So it's different. But remember, they're all parallelograms. I don't know if you guys remember the Venn diagrams we used in 7th grade. Used in 7th grade math that learned rational and irrational numbers, real numbers, put into some groups. When you learned about counting numbers or natural numbers, whole numbers, integers. Worth may not. All right, so this is kind of a Venn diagram. How many sides do all these figures have? 4. So everything in the big blue box is a quadrilateral. What's this look like? What figure is this? Does anybody know? Has 4 sides. What does it look like? Kite. It is actually a kite. Now, a kite is a geometric figure. We know that the 2 shortest sides are congruent and the 2 longest sides are congruent. These opposite sides, or they're adjacent sides. There's some other rules about that, but I think that's all you need to know for now. We will learn more about kites, more specific things about kites. Anybody know what these are? These are trapezoids. So you'll notice the trapezoids and the kites are in the big blue circle. So they're quadrilaterals. They have 4 sides. The thing about trapezoids is their bases are parallel. So it's a 4-sided polygon, and these are the bases. They're parallel. That's a very bad triangle, but you get the gist. So this is the base. There's such thing as a regular polygon. So when we talked about regular, certain regular polygons, that meant all the sides have the same length and all the angles were the same. But in a regular polygon, this one would be a regular polygon. These 2 sides are parallel, and these 2 sides would be congruent. But for now, I don't think you need to know that. But just what is the difference between those 2? Make sense? Now we're getting to more of what we're working with today. Parallelograms. Everything in the big brown box, or whatever color that is a parallelogram. So there's 1, 2, 3, 4, 5, 6, 7 parallelograms. This parallelogram has no particular special name. You can see that this side and this side would have to be the same length. This side and this side would be the same length. Opposite sides would be parallel because we're telling you it's a parallelogram, right? Within this big box of parallelograms, we also have rectangles. So everything in the pink box is a rectangle. So this and this is a rectangle. Does that make sense? Now, I didn't do a good job of this, so let's see if I can fix it up a little bit. So everything in, I don't want that color. Everything in this box I forgot. Hold that thought. Sorry. I did not mean to be creating while I was recording, but sometimes you gotta do what you gotta do. So everything in this black box is a square. Now, this purple box has two things in it. So remember, everything in here is a parallelogram. Parallelogram, 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 parallelogram. This parallelogram and this parallelogram are both a rhombus. A rhombus is a parallelogram that all four sides are congruent. Its diagonals bisect opposite angles. It's got some special properties, right? But one of the things is it doesn't have four right angles. This one is a square is a special rectangle, and a square is a special rhombus. So this is a rhombus. Are you with me? Okay, that's some base knowledge here. So one way we're going to use this, which figures are squares? Squares got to look at our criteria we looked at the beginning. Four sides that have the same length and four right angles. So, is A a square? No. That would be crazy. Is B a square? Is C a square? No, because its sides aren't equal. So which one's a parallelogram? Is A a parallelogram? Look at Devontae looking at her Venn diagram. Good job. It is not a parallelogram. What is it? What's in our Venn diagram? What do we say that is? The kite. The kite and a... All right, let's go back. So a kite is a kite and a quadrilateral, right? A trapezoid is a trapezoid and a quadrilateral. This green one, just a quadrilateral. The parallelogram is a parallelogram and a quadrilateral. The rectangle is a rectangle, a parallelogram, and a quadrilateral. Does that make sense? The square, rectangle, rhombus, and parallelogram, and a quadrilateral, right? So, lost my train of thought. So, this is a kite. Two sides that are congruent here, and these longer sides are congruent here. Is a kite a parallelogram? So what is it? Besides a kite, that's a quadrilateral, right? So that's not. Is figure B a parallelogram? Yeah, and C? Yeah. Which ones are rectangles? A? B? Yes, remember B. A square is a square and a rectangle. Okay? And then, C is a rectangle. Any questions? So a square is a special rectangle and a special rhombus. This is informational. We can see that a parallelogram has all these properties, right? A rectangle is a parallelogram, so it has all of these properties as well. In addition to these two, four right angles and the diagonals are congruent. The rhombus here has all of the properties of a parallelogram, and then it has four congruent sides, diagonals are perpendicular, and diagonals bisect opposite angles. This is angles. It does not bisect any angles. I promise you, it is angles. Let me correct that. And last but not least, a square. I need a good color for a square. Highlight. The square has all of these properties. So it's the most special. All right? Since a square is 4 right angles, a square is a rectangle. Since a square is 4 congruent sides, a square is a rhombus. All right, so one of the things I also wanted to show you guys to be thinking about is all these polygons we're working with, basically we can split them into triangles. So if we're looking at, this is a square. If I draw a diagonal here, this triangle and this triangle, they share this side. These are all congruent. It's 2 congruent triangles, right? If I draw the other diagonal, there's 4 congruent triangles because these diagonals bisect each other and they're the same length. So that's going to make all of these the same length. So on today's assignment, we're going to be using properties of these isosceles triangles. These would be the base angles of an isosceles triangle. I'm trying to refresh the memory here from when we talked about isosceles triangles. A rectangle. So this side and this side are congruent, this side and this side are congruent. We draw a diagonal. We've got 2 congruent triangles, right? But if we draw both diagonals, now this triangle and this triangle are congruent, and this triangle and this triangle are congruent. Does that make sense? Okay. But still, these are going to be isosceles triangles. Okay. I wanted to plant that little seed of a review before we got any further. All right. Some rules for parallelograms. Quadrilateral where both pairs of opposite sides are congruent. This is review. Quadrilateral with both pairs of opposite angles congruent. Yes, we know that. Quadrilateral with the diagonal, we know this. So this is all review. What conditions to prove that a quadrilateral is a rectangle? So if we only know it's a quadrilateral, we can say it's a rectangle if it's a parallelogram with one known right angle. Why would that be? Why does it only take knowing it's a parallelogram and one right angle? Anybody know? Charlie? The sides are parallel. We know it's a parallelogram. How do we know it's a rectangle?
Because you need one right angle, sides are parallel. Just put a right angle on it.
Yeah. So if it's we did state that in one of our lists, but why is that true? Well, aren't opposite angles in a parallelogram congruent? So if that one's a right angle, this one is. And also we know this angle and this angle are supplementary. So they have to add it to 180. So if this is 90, 180 minus 90 is 90. These are also consecutive interior angles. They have to add up to 180. So this is 90, then that one has to be 90, right? If the diagonals are congruent, and so these are 2 ways to tell that the diagonals are congruent, just for your information. They don't mark the diagonals congruent here, but they tell us that AD is congruent to CB. So we have to know AD congruent to CB. Those are the diagonals. Another way to do it is they split these diagonals and they bisected them. But if all 4 parts of both diagonals are congruent, then they are marked congruent. Then we know it's a rectangle. A quadrilateral with 4 congruent angles. The only way to have 4 congruent angles in a quadrilateral is if they're 90 degrees, because we know the sum of the interior angles of a quadrilateral is 360, right? So 360 divided by 4 means that those are going to be 4 right angles. And then we already talked about this one, so I'm not going to go over that one again. All right. Given the information marked, let's indicate which of these things is true. It could be one or some. It could be 1, 2, or all. What do you think? Let's look at the first one. Is this a quadrilateral? There's only one requirement for a quadrilateral. What does quad stand for? Four. Four sides. Quad, four, lateral is side. Four sides. This one is a quadrilateral. It has four sides. They're all quadrilaterals, right? They all have four sides. Is this a parallelogram? Well, the diagonals bisect each other, right? So that's one of the tests. So it is a parallelogram. Is it a rectangle? Looks like a rectangle. But here, it says note that each figure is drawn like a rectangle. You can't just go with that. What is not marked that we need marked to prove that it's a rectangle? At least one right angle, right? So parallelogram, quadrilateral rather. Opposite sides are congruent, so that means it has to be a parallelogram. One right angle, if this is a right angle and it's a parallelogram, then all these are right angles, so that makes it a rectangle. All right, quadrilateral has four sides. These two sides are parallel, and there's a right angle here. Is it a parallelogram? We don't know, right? That is the thing. We don't have enough information. We need to know that these two sides are parallel, or these two sides are congruent as well as parallel, right? So that's as far as we can go there. All right, let's mark some things up. I've marked some things on mine. I've marked the given information. You should definitely be marking your given information. It says in the rectangle below, so telling us it's a rectangle gives us information. In the rectangle below, AE equals 3x plus 6, CE equals 6x minus 6, and the measure of angle EDA equals 28 degrees. Find the links, so the measure of BD and the measure of angle EAB. So I've marked the things. They told us that AE was 3x plus 6. They told us that 3x minus 6. Let me make it a little bigger. They told us that CE is 6x minus 6. So CE is 6x minus 6. They told us that angle EDA, the measure of angle EDA, so EDA, that's its angle, is 28 degrees. They want us to find the length of BD, so this red line, and they want us to find the measure of angle EAB, so EAB. So right here. I'm just going to mark it with a dot. Does that make sense? Okay. What else do we know about this rectangle? Thomas, what else do we know about this rectangle?
We have to measure 28 degrees.
Well, that's a given, right? But what do we know as far as the properties of a rectangle? If you're not sure, you have a little list in front of them on your notes, right? So let's use our notes. So rectangle has all of these things, plus 4 right angles, and diagonals are congruent. Okay? So tell me what I can mark on this rectangle. These are specific to a rectangle. Did they mark the right angles congruent? Did they mark any right angles on there?
No.
Did they mark diagonals congruent?
No.
So can't we mark those on there?
Yeah.
Okay. So there's 4 right angles. I'm going to go with 1 because this is the corner I'm working with. So the other thing it says is diagonals are congruent, and if we look at the parallelograms, we also know that the diagonals bisect each other. So the other thing we know here is that this and this are congruent, which means, and also, remember what it said, the diagonals are congruent. So if this and this are congruent, these two parts are also congruent to this other diagonal. Does that make sense?
Mhm.
Okay. So now, if we solve for x, we could find the length of AE or CE. Would you agree? We'll find x, plug it in, and that gives us the length from here to here. Well, the length from here to here is the same as the length from here to here, right? So we could multiply by 2. Once we know how long this one is, we'll know how long this one is. That's the other thing they asked for, right? Because it's a diagonal are congruent. So we know that the measure of AE is equal to the measure of CE. So once we can find the length of CE, that's not what I wanted to do. Might be AC is equal to, so AC is the whole diagonal, right? Since diagonals are congruent. So the measure of AC is equal to the measure of the diagonal that we want to know the length of, BD. All right. Too much at once, or does it make sense? What do you think, Ashlyn? You're good? What do you think, Xavier? You good? All right. So let's start with solving for x. If these two segments are congruent, we've already said that, the diagonals are congruent. If these two segments are congruent, we can set their measures equal to one another to solve for x, right? 3x plus 6, that length is equal to this length. And then we're going to solve for the equation, solve for x. I'm going to take 3x from both sides, because one of our variables in the same side. That leaves us 6 equals 3x. We need to move this minus 6 away from our x's, so we're going to add, oh, I did it in one step. Oh, no, I didn't. We're going to add 6 to both sides. So 6x minus 3x gives us 3x. Add 6 to both sides, we have 12. Divide both sides by 3, and x equals 4. Make sense, Kellen? All right. So once we know what x is, now we can find the length of AE. I'm going to just plug into this first one. I could have plugged into 3x plus 6 or 6x minus 6. So 3 times 4 plus 6, that's 12 plus 6. So now we know AE is 18. If AE is 18, that means this one is also 18, right? So now we know the whole thing, AC, is 36. So that is the measure of AC, and it's also the measure of the other diagonal, because the diagonals are congruent. So BD. So in our box down here, now we know BD is 36. Okay. This 28-degree angle is a given. Remember what we talked about isosceles triangles? These two triangles are congruent, but we don't really care about that right now. This side and this side of this triangle are congruent. Two sides are congruent, that makes this an isosceles triangle. So we know that the base angles, how do the base angles relate in an isosceles triangle? So the angles across from these legs, those are the base angles, and they're congruent. Right? So if this angle is 28, this angle has to be 28. We could find the measure of this angle DEA, but they don't ask us that, right? We could add these two together and subtract from 180. What they ask us is to find the measure of angle EAB. So EAB. So that's the other part of this right angle. So how can we find the measure of angle EAB now that we know this angle is 28? subtract 28 from 90. That's exactly right. So 90 minus 28. And that gives us 62 degrees. Oh my word, look at the rain. Okay, any questions? So we do have a few minutes for you to work on your assignment. A little over almost 15 minutes. So scan and submit, and that was the last one, right? Yeah. Scan and submit, and then you can get started on today's assignment.